All right, greetings students. Today we are going to do some stoichiometry with gas laws. So to review, we do have temperature at 0 degrees Celsius or 273 Kelvin. This is what we call standard temperature and pressure, STP. And the pressure can either be in 1 atmosphere, 101.3 kilopascals, 760 torr, or 760 millimeters of mercury. It just depends on what unit you're using. The number is going to change. So without further ado, let's do some mole conversion. And let's move up just a smidge. All right, so number one, it says calculate the number of moles contained in 550 milliliters of carbon dioxide at STP. So if it says at STP, that's something should ring a bell. Remember, 1 mole of any gas particle is 22.4 liters. Okay, so at STP, standard temperature and pressure. So that's our conversion factor. But we don't have liters. We have 550 milliliters. So let's do some quick conversion. So we have 550 milliliters. Milliliters on the bottom. I'm sorry, milliliters on top, milliliters on the bottom. And remember, for every 1 liter, there's 1,000 milliliters. All right. So now we got our answer. Oops. Let me go backwards a little bit. So now we should have just move the decimal place. If you're dividing and the zeros on the bottom, you move the decimal place and it's going to be a small number. So 0.550 liters. And now since liters are on top, where do they go next? Well, they're going to go on the bottom. And what's our conversion factor? We're trying to figure out moles. Well, this is our conversion factor right here. So we can put 22.4 on the bottom and 1 mole on the top. Okay, let's get out pinky. And we have 0.55 divided by 22.4. 0.55 divided by 22.4. It helps turn it on. And you should get exactly what we have right here. 0.0246 moles of carbon dioxide. Okay. So essentially all we did was just for this problem, all we had to do was we're giving liters and we went to moles. That's it. That's all we had to do. The only problem was our starting material was not in liters. It was in milliliters. So we had to do a quick conversion between milliliters to liters, and then we can go from liters to moles. All right. All right. Next question. Let's move on, moving on down. Let's do blue again. Calculate the number of grams contained in 500 milliliters. Okay, so we're looking for grams of carbon dioxide at STP. So remember, 1 mole of any gas is 22.4 liters. All right, so our starting material is milliliters. And we know that we can go liters to grams, but in order to do so, we need to bridge the gap between moles. So we're going to go liters to moles to grams, okay? The only problem is we don't have liters, we have milliliters. So there's 1,000 milliliters in every liter. So we're going to divide that, and what you're going to get is 0.5 50 liters. Okay, so now we have liters, check. Let's convert to moles and let's go to grams. Whenever you're using liters, keep in mind that in order to bridge that gap, we're going to use 22.4 liters. And remember, whenever you use grams, you're going to use the P table. Okay, every single time you hear the word grams and you're doing stoichiometry, you've got to use the P table. So let's do our conversions. So we have 0.55 liters of CO2. Liters is on top. We're going to do our first step. Liters is on the bottom. We're going to use 22.4 for every mole of CO2. And now we're going to effectively go to moles. So for every mole of CO2, remember top to bottom, top to bottom, top to bottom, we're going to figure out how many grams of CO2 there are. So if you look at your period table, carbon weighs 12, oxygen weighs 16, 16 plus 16 plus 12 should equal to 44 grams. Now, we are not cross multiplying. Everything is on the same side of the equal sign. So we've got to multiply the tops and divide by the bottom. So get out your calculator, get 0.55 divided by 22.4 times 44. Okay, and you should get 1.08 grams of CO2. This should be review. We're just doing our mole map. Look in your notebook. All we're doing is we're just going from either liters to moles to grams or moles to grams to liters. That's it. All right, let's do the next one. Calculate the volume in liters of 50 grams of nitrogen dioxide at STP. So we know that we're going to use 1 mole equals 22.4. So we have grams. So what we're going to do, grams, oops. And we're going to end at volume. So we can't go grams straight to volume. We have to use mole. And then remember, mole is always the middleman, okay, in order to go from grams to volume. So again, I'm going to be using the P table every single time you see grams and you're doing some sort of conversion. That's going to get me into moles. How do I go from moles to volume at STP? We're going to use 22.4 liters. Okay, so let's do it. Our starting material is 50 grams of nitrogen dioxide, NO2. Grams of NO2 on the top, grams of NO2 is good to go on the bottom. Oxygen is 16, there's 2 of them, plus 1 nitrogen, so 16 plus 16 plus 14. 16 times 2 plus 14. You should get 46 grams on the bottom. And now we have switched to moles. Now 1 mole on top, 1 mole on the bottom, and then we're going to switch to liters and we're going to do 22.4 liters. All right. Everything is on the same side of the equal sign. There is no cross multiplication occurring. Repeat, no cross multiplying. So we are going to multiply all the tops and divide by the bottoms. So let's take 50 times 22.4 divided by 46 equals 24.3. Perfect, we got it. Wunderbar. All right, those were easy. Let's go on to something a little bit more challenging. Now, we're going to start talking about when we can use 22.4 and when we cannot. Up to this point, we've always been able to use 22.4. Some of you guys are wondering, how in the world did we come up with this number? Well, we came up with the number when solving for PIVNERT. PV equals nRT. As long as you're using the correct units, you'll get 22.4 every time. Liters is volume, so let's rearrange the formula. So volume, remember we need to get rid of P, and the only way to get rid of it if it's on opposite sides of the equal sign is to crisscross applesauce. So we're going to have nRT divided by P. So let's get our volume out. If we just say 1 mole, because 1 mole of any gas at STP is 22.4, but let's figure out what that is. So 1 mole. And let's use atmosphere for our pressure. So remember STP, oops, it's on the other slide. Remember STP is 273 Kelvin, because we have to use Kelvin for our temperature, which is the same thing as 0 degrees Celsius. Remember, it's when water freezes at sea level. That's one way to remember it. When we use pressure, we remember we have to use a specific R, and when we use kilopascals, we have to use specific R as well. So keep in mind, when we use atmosphere, our R value has to be 0.0821. And when it's kilopascals, we have to use 8.31. All right, so if we're going to do atmospheres for pressure, the R has to be 0.0821. And then the temperature at STP has to be in Kelvin, so it's 273. And if you multiply and divide, which you should just be dividing by 1, so it should be working out okay. 0.0821 times 273, you should get, oops, 0.0821 times 273, you should get 22.4 and some change. Now, the reason why it's not exactly 22.4 is because we're not using exact numbers. 273 actually has a little bit of digits after, it's like 0.15, so it's fine. 22.4, we should get it. Perfect. That's where 22.4 liters comes from. 1 mole at 1 atmosphere at 273 Kelvin or 0 degrees Celsius, okay? What happens if you wanted to use kilopascals? I know we haven't really used it that often. So what happens if I want to use kilopascals? Well, that means I have to change my R value as well. So here we go. So if we're using pressure at 101.3 kPa, kilopascals, then we have to use a different R value. So it's 8.31. You should get the exact same thing. 8.31 times 273 divided by 101.3, 22.4, done. All right, now we're gonna do some Stoich problems. Remember, stoichiometry just means that we're combining mole conversions, like going from grams to liters to moles, with a chemical formula. That's all stoichiometry is, mole conversions with a chemical formula. All right, mole conversions is when you just keep the same molecule. Stoichiometry, since you have a chemical formula, you're gonna hop from one molecule to the next, okay? All right, so it's really not that hard. You just have to keep track of your units and keep track of what you started with and what you need to find. So it says, how many liters of nitrogen? So which one is nitrogen? Nitrogen is a diatomic molecule, so therefore it is N2. So we're looking for question mark liters. That's what we're looking for. Is produced if 50 liters of water. So we have 50 liter water is produced at STP. So that means 1 mole is 22.4. Okay. Liters. Now, how do we get to 25 liters? Well, what we're going to do is we're going to always start with our given, okay? And here's our given, and we're going to go to our find. That's what we need to go. In addition to that, we're going to be using these numbers in the front, okay? If it's blank, it's going to default to 1. Since I'm not using, or I'm not, I don't have to use the reactants. Actually, I can't use anything from the reactants because all we're doing is comparing products. I'm literally just going to scratch that out. So essentially what we're going to do is we're going to start with a molecule. We're going to do some mole-to-mole conversions, and then we're going to end in liters. Okay? So we have liters, moles, and then we're going to make the handoff. Okay? Mole-to-mole ratio, and then we're going to end in liters. And that's it. Okay? Let's go back to blue, our starting material. So we start with 50 liters of H2O. Now this problem is a little bit redundant because we're going liters to liters at STPs, and you'll see it in a second. Liters is on top, liters gets to go on the bottoms, and we're going to use 22.4 liters for every 1 mole of H2O. Okay. Now this is where we make the handoff. Right here. Water has a 2 in front, okay? Water has a 2 right here. Nitrogen has a 1. If you're not keeping track of your units, you will make the mistake of putting the 2 and the 1 in the wrong spots. All right. So since mole of H2O is on top, mole of H2O is going to go on the bottom. What's the number in the front in the coefficient for water? 2. All right, now we're going to make the handoff. Mole of N2. What's the number in the front, the coefficient? A 1. And now we're going to go back to liters. So for every 1 mole of anything, it is 22.4 liters. This cancels and this cancels, which leaves us with 50. And since we're going down, we are dividing. Remember, everything is on the same side of the equal sign. So we are 50 divided by 2. You should get 25.0 liters of N2, which makes sense because, look, it's a 1-to-2 ratio. All right. That is when we use stoichiometry at STP. We can use 22.4, easy peasy, lemon squeezy. What happens if we have the exact same formula, but we're not at STP? Okay. And to make things on a little bit more difficult, we're going to solve a different aspect of the formula. So let's figure out what we have and then figure out where we need to go or what's the unknown. Try to scratch off as much as we can. So it says, how many liters of water vapor? Question mark liters. We know that we need to eventually get down to liters of water. Is produced if 4 grams of ammonium nitrite, 4 grams is produced, oh, that's a typo, is used, or I'm sorry, it should have said consumed, or perhaps decomposed. If 4 grams decomposed, this is the decomposition reaction. Wait a tick, we don't have STP, but our pressure is 2.5 atmospheres. Our temperature they gave us is 25 degrees Celsius. So we don't have that quick, easy 22.4. So we have to do some stoichiometry. And then, so what we're going to do is we're going to do some stoich. Which all stoichiometry means is just doing mole conversions from different molecules. So we're going to do stoich, and then we're going to take the answer from stoich and then put it in our ideal gas law. That doesn't make much sense right now, but let's see what we have. Remember we're using atmosphere. So our R is going to be 0.0821. We know that we have to solve for question mark liters of water. The only thing that is really preventing us from just using the PV equals nRT formula is number of moles. We don't have number of moles. We don't have number of moles of H2O. Instead, we have 4 grams of NH4NO2. All right, so what we're going to do is we're going to do some stoichs. So we're going to take this. Remember, this is a 1 in front, and that's a 2. We're going to do our, let me see if I can make this a little bit smaller so we can have room to write. Okay. So let's do some stoichiometry. We're going to take 4 grams as our starting material. Essentially, what we need to do is stop at moles here. And once we find our moles of water, then we can plug it in the formula and solve for our liters. Okay? So this is what we're focusing on right now, so that later on we can plug and chug and solve for liters. Remember, because you can't use 22.4. It's not at STP. It's at a different pressure and temperature. So let's solve for N, the number of moles of water. That's what we're doing right now. So let's use our starting material, 4 grams of NH4, NO2, grams on top, grams on the bottom. 2 nitrogens, that's 14 plus 14. Hydrogens, that's 4, each one is 1, there's 4 of them, plus 16. So let's do let's do nitrogen is 14. Hydrogens, 4 of them is 4. Nitrogen is 14. Oxygen is 16 plus 16, that's 32. So you should get 64. All right, let's do a mole to mole ratio. We know that we have a 1 It's a 1 mole. This is our, all right. And then we know that water has 2 moles of water for every 1 NH4NO2. Okay. Now, the reason why we are going to stop at this juncture is because we cannot just go and do for every 1 mole, there's 22.4 liters and solve for liters. We cannot do this because we are not at STP, okay? So we have to solve for moles and then put it in our plug and chug, our PV equals nRT formula, our PIVNERT, okay? So what we're gonna do is we're gonna stop there. So we have 4 divided by 64 times 2 is 0.125 moles of water because NH4 canceled, NH4, 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 which leaves us with water. Now that we have our moles of water, we can plug and chug. To see how it's really important to keep track of your units and just not numbers without units and molecules. So we have 0.125. All right, let's plug and chug our PV equals nRT formula. So we have PV equals nRT. We're going to rearrange the formula with nRT over P. The number of moles in which we solved for was 0.125, 0.0821. Our temperature, oh, we got a boo-boo here. We need to add 273 to that, equals 298. You cannot put Celsius in a PIVNERT equation in the gas laws. And then divided by the pressure is 2.5 atmospheres. So here we go, 0.125 times 0.0821 times 298 divided by 2.5. And you should have got 1.22 liters of H2O. You can do it